Today we talk one important topic related to linear transformation and matrices. Especially we connect it with homogeneous linear differential equation. Okay, this topic. We now start from one lemma. Okay, important lemma. We first write it in statement of this lemma. The differential operator d differential, okay, such that here c infinity to c infinity, okay, is onto for any complex number, is onto for any complex number c, okay, is onto for any complex number c. Understood? Okay, now we also going to discussion of proof. This one is too easy. We have to prove that t differential be onto. Okay, now let y belongs to c infinity. Okay, then what happened? We wish to find a u belongs to c infinity. Okay, such that t differential of u equal to p. Okay, let what happened here. mm, Let this one, sorry, here v belongs to c infinity. Okay, then this v. Okay, that means for every v we get some u. Okay, so we also take v belongs to c infinity, not y belongs to c infinity. Then let wt equal to what? Equal to vt to the power minus ct. Okay, 40 belongs to r. Clearly this one is clearly w belongs to c infinity. That means this one obviously infinitive time Drahel function. Okay, then what happened? Then this one happened. Why? Because right here, because both, okay, because both p and e to the power minus ct, okay, lie in c infinity. Okay, and then what happened? Then let w1 and w2 be real and imaginary parts of w. Let w1 and w2 be the real and imaginary part. Be the real and imaginary part of w. Okay. Then what happened? Then then w1 and w2 are continuous. Then w1 and w2 are continuous. Okay. And what happened? Mm, then w1 and w2 are continuous because they are differentiable. Because they are differentiable. Okay. Then what happened? Then we also see that then they have antiderivatives. Okay. Then they have antiderivatives. Okay. Then they have antiderivatives. Say capital W1 and capital W2 respectively. Okay. Then what happened? we erase our portion and going to further discussion of that. Okay, let the capital W, obviously R to C. Okay, R to C be defined by what happened. Capital W T equal to capital W1 T plus I W2 T. Okay, then what happened? 40 belongs to R. 40 belongs to R. Then, then W belongs to C infinity. Okay, and the real and imaginary parts of W, and the real and imaginary parts of W, imaginary parts of W. Okay, and the real and imaginary parts of W are W1 and W2. Okay, respectively. Capital W1 and capital W2 respectively. Then what happened? Then furthermore, W dash equal to small w. Okay, capital W dash equal to small w. Then what happened? Okay, mm, then finally let U, okay, belongs to R2C be defined by ut equal to here capital WT e to the power CT. Okay, 40 belongs to R, and then U belongs to C infinity. Not a problem at all. WT is C infinity function and WT e to the power CT is C infinity function. And since okay, since what happened? Since d difference Ci of ut, not v, ut equal to what happened? We write it here. Here this one is u dash t difference c of ut. Okay, u dash t and c of ut. U dash t equal to what? U dash t equal to w dash t. Okay, e to the power ct plus wt e to the power ct. Okay, here's c, and difference c of ut equal to c of wt e to the power c. Okay, then what happened? This one equal to w dash capital W dash t e to the power ct, then small wt e to the power ct. Okay, then this one equal to what? Small wt equal to here vt e to the power minus ct, then this one equal to pt. Understood? That means d difference ciut equal to v2. Okay, then we write it here in this way: d difference ci of ut equal to v2. Okay, then what we get? We get our required, that means result. We have to prove that t difference ciu equal to v. Then we also show that this one is on 2. Okay, d difference ci, this operator be on 2. So this one be on 2. Understood? So what we do? We just, that means let some wt will equal to vt to the power minus ct, then w, the small w belongs to c infinity, since v and e to the power minus c is both c infinity, okay, in both c infinity, then what happened, then obviously we say about that w1 and w2 continuous and obviously have anti-derivative, okay, they are differentiable and continuous and obviously have even anti-derivative, then w be the anti-derivative and w1 and w2 are real and imaginary part, okay. So w belongs to c infinity and w dash equal to capital W dash equal to small w. Then we take u equal to ut equal to w capital W t to the power ct, then the difference ci ut equal to we get vt. Okay. So in this way we also discuss the total result, and obviously we get this result t different ci ut equal to vt. So in this way we also prove this lemma, and obviously step by step we're going to power and reach this onto this result t difference cib onto. Now we that means it is that portion and going to further discussion of another lemma. Okay, we write it here lemma. Okay, then let V be a vector space. Let V be a vector space. Okay. And suppose that T and U. Suppose that T and U. Okay. T and U are linear operators on V. Are linear operators on V. Okay. T and U are linear operators of V such that U is on V. Such that U be on V. Okay, such that U be on two, and the null space of T and the null space of T, okay, null space of T and U are finite dimensional. T and U are finite dimensional. Okay, then what happened? Then the null space of then the null space of Tu, okay, null space of Tu is finite dimensional, is finite dimensional, and dimension of null space of Tu equal to what? Equal to dimension of nt plus dimension of nu. Okay, we have to show this ones. Okay. So V be a vector space and T and U are linear operators on V. Okay. So we have to show that T U be onto is given. Okay. U onto is given and null space of T and U are finite dimension. This one is given. Then we have to show that null space of T is finite dimensional and dimension of null space of Tu. Okay, that means nullity of Tu equal to nullity of T plus nullity of U. Okay, we have to prove that. So we write proof and going to forward step of that. Let P equal to dimension of NT. Okay, and Q equal to dimension of NU. Okay, and here u1 u2 up u1 u2 up small, and here v1 v2 vq v1 v2 dot 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 vq. Okay, the basis for nt, the basis for nt and NU respectively. Okay, then what happened? Then since U is onto, okay, we write it here, since U be onto. So what happened? We can choose for each I, we can choose for each I. Okay, 1 less than equal to I less than equal to T. Okay, sorry, not N, T. A vector Wi, a vector Wi, okay, belongs to V such that what U of Wi equal to P U, here U of Wi equal to small ui. Okay, understood? That means U be onto this implies this one. We can choose for each I a vector Wi such that this one is whole. Now we erase our portion and going to further discussion of that. Okay, so we start from here, this one. Now we note that note that Wi's are distinct. Okay, Wi's are distinct, and furthermore, for any I and j, for any I and j, okay, Wi not equal to Vj, Wi not equal to Vj. For otherwise, okay, Ui equal to capital Uwi, okay, then this one equal to capital U Vj, okay, equal to 0, a contradiction. That means this one, if Wi not equal to Vj happen, okay, if otherwise happen, then this one is done. U of Wi and U of Vj equal to 0. Okay. Then what happened? Then we note that Wi's are distinct. Note that Wi's are distinct. Okay. Here Wi are distinct, we also write here. That means this one is not needed here. We're also going to further. Hence the set. W1, W2, WP, and here P1, P2, PQ. Okay, contains P plus Q vectors. Okay, then what happened? Then to complete the proof, it suffices it. Then we have to show that. Okay, we have to show that what this one beta is a, this one we mark as beta is a basis for, okay, basis for n of t. Understood? If we show this one, then our proof is done. Okay, so we start to show this one. Okay, that means we first show that show that beta generates T N T E. Understood? Then what happened? We write it in this way: since for any W1, any W1, okay, sorry, any WI and VJ, okay, in beta, any WI and VJ in beta, then T of U of WI equal to T of UI equal to 0, okay. Then what happened? And obviously Tu of Vj equal to here T of 0 because U of Vj equal to 0, okay. Then and obviously T of Ui equal to 0, okay. Then what happened? Then this one equal to 0, okay. It follows that it follows that it follows that what? That means this one beta subset of n of T. Okay. Now we suppose that now suppose that okay, V belongs to n of Tu. Then what happened? Then 0 equal to TUV. Okay. This one equal to T of UV. Then what happened? We erase our portion and going to further discussion that okay. Then what happened? Thus UV belongs to UV okay belongs to n of T, okay. UV belongs to n of T. Then so there exists scalar. So there exists scalar A0, A1, A P such that what UV equal to okay A1 U1 A2 U2 AP UP. Understood? Then what happened? This one equal to again we write in this way A1 capital UW1 A2 capital UW2 and AP capital UWP. Okay. Then what happened? Here we write this one equal to U A1 W1 okay A2 W2 AP WP. Then this one equal to what? Then hence we write hence U of V difference this one A1 W1 A2 W2 APWP is 0, okay. Consequently we write okay consequently okay V difference A1 W1 A2 W2 APWP equal to what? Lies in NU. Okay. It follows that it follows that there exists scalars B1 B2 here BQ such that okay V difference A1 W1 A2 W2 APWP equal to what? B1 V1 PQV. Understood? Then what we write here this implies that v equal to a1 w1 a2 w2 apwv and v1 v1 vq. Not a problem at all. This one, that means we written here. Okay. Then this implies that v is in basis of. Okay. Mm, then p obviously belongs to linear span of beta. Okay. Then obviously beta span t, since v is arbitrary, so beta span. So after that we write here, what we write in this way, this one, that means v is in the linear span of beta. So v belongs to linear span of beta. Okay, and this implies that, okay, beta spans NTU, since beta is arbitrary. Okay, sorry, since v is arbitrary, so beta spans this one. Not a problem at all. Then we have to show that, okay, we have to prove that what we have to prove that beta is linearly independent. Beta is linearly independent. Understood? We have to prove this one. Then what we do? Let a1, a2 ap, okay, and b1, b2 bq be the any scalars such that what, a1 w1 a2 w2 ap wp, and here v1 b1, here v1, okay, v1 v2 p2 bq pq equal to 0. Okay, we choose this relation, we mark this 6. Then what happened? That means now we apply u to both sides of 6, we get, okay. Then what happened? a1 v1, okay, u of w1 equal to what? U of w1 equal to u1, okay, u1. Then a2 u2 ap up, okay, and other ones are 0. U of v1, u of p2, u of vq is 0. Okay, since v1 v2 vq belongs to nullity of, okay, so this one obviously 0. Okay, now we write, since u1 u2 up be linearly independent, okay, be linearly independent, so what happened? ai's are 0 for all I equal to 1 2 okay. Then again, then 6 becomes what? We write here, then 6 becomes, okay, v1 v1 v2 v2 here vq vq equal to 0. Okay, then this implies what? That means again we write independence of p1 p2 pq, again the linear independence linear independence linear independence of v1 v2 vq v1 v2 vq. Okay, vq implies that implies okay, we write in above. It is above portion I'm going to discuss of that. v1 v2 vq implies that vi's are okay, vi's are 0, all 0, since v1 v2 vq are linearly independent. Okay, v1 v2 vq are linearly independent and belongs to n of t, and u1 u2 up is then linearly independent and obviously belongs to n of t. Okay, then what happened, then we write it here. Then obviously beta is a basis, that means beta is a basis for n of t. Okay, beta is a basis for n of t, hence n of tu, hence nullity in null space of tu. Okay, is finite dimensional, is finite dimensional. Okay, and dimension of n of t equal to t plus q. Okay, then equal to dimension of nt plus dimension of nu. Okay, not a problem at all. So we discuss whole portion. Dimension of n of t equal to here dimension of nt plus dimension of nu. How this one is evaluated we also discuss step by step. Okay, now that means we stop here. Today we discuss two lemma. One lemma also give t minus ci, this operator be onto, okay, for any complex number c. And second one is dimension of null space of t u equal to dimension of null space of t plus dimension of null space of u. Okay, this one we discuss today. So today we stop here. If you get this type of video, please subscribe my channel. If you have any question, comment, suggestions, write it in comment box. If you want to give like, please click on like option. Thank you. We stop here.